This is an example for how to build a simple circuit on Tinkercad. So first I'm going to go into my circuits and click on New and select a circuit. That is that I want a new circuit, to build a new circuit, and this is what I get. Now I'm going to need a prototyping board, so I'm going to click on this and then move my mouse just about anywhere. I don't need to hold it down, and then click in some place to mount this component. Then I'm going to need power, so I'm going to select a battery, put over here. Now the electronic circuits that we want to build will use about 5 volts, so I'm going to need more than just one battery. So over here I will select that I need 3 batteries, and so now I have 4.5 volts. Now that should be enough. Ideally I would want 5, but 4.5 should be okay. And I can rotate this if I want, but I do not need to. I'm going to simply move it over here so it's a little bit out of the way, and then I'm going to connect the leads of the battery to my probe board in order to power them. So these channels, as you see, if I try to mouse over one of the channels, it highlights all the connected slots. So there is a channel behind this that connects all of these slots together, and there is an independent one over here, and similarly over here and here. These slots are connected vertically, but they do not cross this main channel over here. So these will be connected from here to here, and this will be an independent channel that's connecting from here to here. Now I'm going to put my negative to the negative channel. So clicking on the lead, then clicking over here to make an angle, and then clicking over here makes a connection. If I want, I can change the way that this is shaped by moving this, but I'm going to leave it where it is for now. I'm going to also connect this lead to this channel over here. So now this is going to be my ground, and this is going to be my power. If I want to have ground and power on both, I can also connect them like this. So I can put a wire from here to here. So now both of these lines can serve as ground, and I can connect another wire from here to here, and I can make it a different color so that I can distinguish them. So now both of these are serving as either ground over here or power channel here and here. Next, I'm going to need to use something for inputs, and I'm going to use a switch, like a slide switch like this, and I will place this switch right here, and I'm going to use an LED to indicate the status of my input. So I'm going to select an LED from here and stick it over here. The input that I will be using will be the middle pin of my switch. So this one will be accessible from all of these slots. So I can connect this slot to my LED, and then I'm going to need to connect the LED to the ground. So I'm going to need a resistor, which I'm going to place right here, and then I'm going to need a lead from here to the ground like this. Let me make this one black so that and make this one black too. And then I'm going to need to connect my switch to power and ground respectively. So I want this switch, when it is to the left, to give me 5 volts, or the power. Well, it's going to be 4.5 over here because I have 3 batteries. And so I'm going to connect this lead here to the power, and I'll make it red. There you go. And I'm going to connect this lead to ground, and I'm going to make it black, like that. Now, this switch, whenever it is on this side, the power will be connected to the middle pin, and so we will be powering the LED, which should light up. And then if I slide this to the right, then ground will be connected to the middle channel over here. So depending on what the position of this switch is, the appropriate pin, either this one or this one, will be connected to the middle terminal. Of course, you cannot switch the position of the switch until you start the simulation. So let's start the simulation just to verify that this works okay. As you see on this side, the LED lights up, and if I click on this to toggle it, then the LED is getting a ground signal, therefore it will be off, okay, like this. All right, now to continue the design, I have to stop the simulation, and I'm going to need to add a new switch because I'm going to need 2 signals. So adding another switch in the same way that I did before, I'm going to put it over here, and I'm going to put an LED right here, and then I'm going to connect this one to the ground like I did before, and I'm going to connect this one to the ground as I did before, get a resistor and place it right here. Okay, so this one is not in the right position, so I need to move it. So I click on this to highlight it, and then I take the end of it and I put it like that. I can leave it like that, but I'll just move this one too, like this. And of course, I need another wire to connect this this lead to power, and I'm gonna make it red. And then I need from the middle pin another wire to connect to the pin of the LED, like this. Okay, so now I have my 2 signals that I will be using for my circuit, and that will be this terminal from this switch and this terminal from this switch. Now I'm going to put a chip on it. I'm going to use a inverter chip. So if I start typing over here for searching, it will give me options here. So here is a hex inverter, the chip 7404. So I click on this, and I need to go and place it on the board, and I'm going to place it right here. And I'm going to need an AND logic circuit. So I'm going to select the quad AND gate, the 7408, and I'm going to place it right here. Now, if I need to see the schematic for a gate, I can simply Google it. And as you can see, the 7408 chip has this internal arrangement. So it has 4 AND gates, although I'm only going to need 1. So I'm going to use pins number 1 and 2 as inputs, and number 3 as output. The arrangement for the NOT chip, the 7402, is similar, and it can be Googled to see the arrangement again if you like. But I do know that there is a NOT gate between this pin and this pin. So what I'm going to do is to build a circuit for this very simple expression, A AND not B. So I need to invert the signal B and then end it together with the signal A. So this LED or this pin right here would be my signal A. So let me label it. So for easy reference, so I'm going to label this, put it right there, and that's going to be my signal A. Like that. And this one will be my signal B. So this will be my signal B. Okay, let me just move it right there. And so now what I need to do is I need to invert the signal B. So I'm going to take a wire from here and I'm going to connect it to this channel right here. So it connects to this pin. And then the output, the inverted output will be over here. The AND gate that I'm going to use is going to be inside this chip, and this pin will be one input. This will be another input. You see, when I hover my mouse over the pins, it tells me what they are. And then this one will be the output. So then I need to connect a wire from this channel, which is going to be the output of the inversion of the signal that I've put over here. So I'm going to put a wire from here, click, 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 and click. So that now inverts this signal. This is the inverted signal that goes into the input of this chip, this one right here. And then I'm going to need the signal A, which comes from here, and I need to connect it to the second input of this gate. So I'm going to click over here, and I'm going to click on an empty space here, and then go all the way over here, and I'm going to put another click there, and then a click right there. And let me change the color to purple so that I can trace my circuit easier. Now I can use the wheel of the mouse to make the circuit bigger if you would like to see it better. And so now I have my signal A connecting to the one input of the AND gate that's over here. I have my signal B inverting over here, connecting then from this output to the other input of the AND gate. And now this one over here is going to be the output which implements the function A and B not. Now I would like to be able to see the output of this signal. So I'm going to use another LED. I'm going to go to the basic components, get another LED, and I'm going to put it over here. And then I can change the color of it if I want. I'll make it blue. And then I need to put a wire from here over there. So I can connect a straight wire from here, click and click like that. Now that wire connects only this channel with this channel. The other channels are not connected. Okay, this does not interfere at all with the channels underneath. But if I would like to make it more obvious, I can double click on this, so it puts one more handle for the wire over there, so I can drag it out like this, put another handle over here with a double click, and drag it out like that, so it makes it more obvious. And now I need to ground the other lead of my LED. Now this is not correct. It's not going to work. I'm going to tell you right away that it's not going to work, but let's just go through the hoops. So I'm putting a resistor over here that grounds this channel to the ground channel over here. Maybe I should have made this one a black color. Okay, so that there's no confusion that this is in fact a ground channel. And now my circuit is actually ready to test. So I'm going to make it a little smaller so that it fits on my screen. And now if I start the simulation, you see that I have a few errors here. So this one here indicates an error. The reason for the error is that I have not powered these chips. So I'm going to stop the simulation and I need to power the chips. This pin needs to be connected to power. On the 7400 family, this pin is always going to be the one that requires the power, and this pin over here is going to be the one that requires the ground. So I need to draw a line from here to here and do the same thing for this one from here to here and from here to here. I should also make this one red since it's power, just to be consistent with my color coding, like that. And then my chips should work. So if I start the simulation again, you see that my chips, in fact, do not give me any trouble anymore. And this switch is on, so this LED is on. This switch is off, so this LED is off. If I toggle, then the LEDs show me what I'm providing as inputs. Now, this LED here doesn't seem to respond, and the reason it's not responding is because I connected it wrong. This one here is the anode, and it is the one that I need to power. This one here is the cathode for the LED, and that is the one I need to ground. So what I need to do is I need to click on this, move it over. Oh, I have to stop the simulation, otherwise it will not allow me to modify the circuit. So I click on this and then move it over like that. And then I need to take this wire and I need to move this one over here like that to be neat. Okay, now it should work fine. So if I start the simulation, I can click on these and the LED will be responding exactly like the function A and B not. In this case, A is true, B is false. Therefore, with the inversion, it will become true. So this AND gate sees two inputs that are both true. Therefore, its output is true, and this one lights up. If I toggle any of these, then my LED will not come on until I have the correct input combination, which is A and not B, like this. And that is it.